No.
So in this last example, this is very similar to an example we did at the end of section 3.3, but now it has a combination of functions. So if we look at what's happening, on our original graph, we have the point 0, 8, and we have the point 2, -8. And now more than one thing can happen, and the point 0, 8 ends up at -2, 0, and 2, -8 ends up at 0, -8. So whereas before, when you just had one set of transformations happening, when you just had stretches and compressions, you could figure out, oh, how do I go from 0 to -2? Well, maybe I'll say I want to go left 2. But left 2, does that work for this one? Yes, it does. Right? So we could say maybe we're just going left 2. But then here we might have a problem because how do I go from 8 to 0? I have to go left or down 8. But this one's not going down 8. So that's where we have a problem when there's more than one thing. And so we introduced a technique in the last example where we started by comparing horizontal and vertical distances in the original graph and the image graph. So if we look first at our horizontal distances, from A to B is a distance of 2 horizontally. And from A prime to B prime is also a distance of 2. It doesn't change. Technically, that means we have to multiply x values by 1, but it means that there's going to be no horizontal stretches and no horizontal compressions. When we look at our vertical distances, though, from A to B, if we start up at the top at A at 8 and we go down to B, we go down 16. And from A prime to B prime, we only go down 8. That means our y values have been multiplied, and they've been multiplied by a half. So now we have information from here to put over top of our first arrow. X by 1 you don't need to write because it's not changing anything, but we do have a vertical compression. Our y values are getting multiplied by a half. If we do that, what happens? We get 0, 4 and 2, -4. Is that good? And now we just have one arrow to go. These are translations. So now we should be able to just figure out. We already figured out that left 2 worked for both of them. So we know that that's going to happen. How can I get from 4 to 0? And does that same rule happen from -4 to -8? -4, so we need to go down 4. Can we take that information and write the equation of the blue graph, g of x, in terms of f of x? So, writing the equation in terms of f of x. Two options here. I could write y equals, or I could write, because it's g of x, I could write g of x equals. We want it in terms of f, so I need to have the function f on the right-hand side. So in terms of the function f, we need y by half. That's going to be outside the function. Left 2 is going to show up inside the function, and down 4 is going to show up outside the function. If you wanted to verify that this works, you could check. Do we multiply y values by half? Yes. Do we move them left 2 and down 4? Does that match up with the corresponding points on our actual graph? Yes. All right, question number 9 for practice, and you can work on those for the last 5 minutes.